From the first moment humanity looked at the birds and dreamed of rising into the sky, a single idea has haunted us: the desire to break free of the earth and explore what lies beyond. That desire has evolved from fragile wooden planes trembling in the wind to powerful jets that cross oceans in hours, and from rockets that shook the ground beneath them to spacecraft sailing through the vacuum of space. The field that has carried us on this journey is aerospace engineering, a discipline that combines imagination with mathematics, vision with physics, and daring with the precision of science. It is the story of how human beings took a dream as old as civilization and turned it into machines that can fly, soar, and even leave the planet behind. It begins with the oldest question: how can something heavier than air defy gravity? For centuries, humanity's attempts ended in failure, but the Wright brothers, with their rickety machine of wood, cloth, and courage, managed to stay aloft for just a few seconds in 1903, and in doing so, they opened a door that would never be closed again. That fragile moment became the seed of an industry, and that industry has since grown into one of the most sophisticated and daring fields of human achievement. From that day forward, the sky was no longer a limit, it was the beginning. Aerospace engineering is not just about airplanes or rockets, it is about every stage of flight, within the atmosphere, at its edge, and beyond it. Engineers who work in this field are architects of the impossible. They imagine vehicles that can slice through the air at supersonic speeds, rockets that can endure the fury of launch and the silence of space, satellites that orbit our world and connect us in ways we take for granted, and spacecraft designed to venture farther than any human has ever dared. Each creation begins as nothing more than an idea, a sketch, each on paper or a line on a computer screen. Yet from that fragile vision, an entire machine is born, massive, complex, and alive with purpose. Consider the airplane, the most familiar child of aerospace engineering. To passengers, it may seem simple: a cabin, wings, engines, and a crew. But behind that simplicity lies staggering complexity. Every curve of its wings has been refined through supercomputers that simulate the invisible flow of air. Every material in its fuselage has been selected for strength, lightness, and endurance, able to withstand years of pressurization cycles that push the limits of metal and composite. Its engines are cathedrals of fire and steel, where thousands of parts rotate and ignite with precision so perfect that failure is almost unthinkable. When you sit in a seat and fasten your belt, you are not merely boarding a machine, you are stepping into the result of millions of hours of thought, testing, and design. Yet aerospace engineering did not stop at planes. The moment rockets entered the scene, the horizon shifted from clouds to stars. A rocket is a different kind of beast. It must carry within itself all the fuel it needs, burning it with such violence that the ground shakes for miles, and yet every fraction of its structure must be balanced, calculated, and exact. The margin for error is razor thin. One miscalculation, one overlooked flaw, and the result can be devastating. Yet the rewards are unmatched. The ability to leave Earth behind, to escape gravity, to touch the void where no bird has flown and no wind has blown. The launch of a rocket is not simply an engineering feat, it is a ritual of human ambition. From the moment the countdown begins, every sensor, every circuit, every engine is alive with potential energy. Then comes ignition, and the air itself seems to shatter with sound. Fire pours from the engines, a column of flame brighter than the sun, and slowly, impossibly, the machine begins to rise. It is the closest humanity has come to capturing the raw power of nature, and yet it is entirely crafted by our own hands. Aerospace engineering is the art of taming that fury, of directing it with precision so that a rocket weighing hundreds of tons can glide into orbit with grace. Orbit is a strange place, a balance between falling and flying, and it is here that satellites, another child of aerospace engineering, perform their silent service. Each satellite is an outpost of human knowledge, a small machine drifting endlessly in the darkness, but its role is immense. They connect our phones, guide our airplanes, map our world, and study the weather. Some gaze deep into space, capturing light from galaxies millions of years old, while others watch the fragile curve of Earth, reminding us of the planet we call home. They are testaments to the quiet power of engineering. Devices launched in a violent storm of fire, only to spend decades floating in silence, never tiring, never faltering. But aerospace engineering is not content with the present. It constantly seeks the future. Engineers are working on hypersonic aircraft that can cross continents in an hour, spacecraft that can ferry humans to Mars, and reusable rockets that take off, land, and fly again like airplanes. They are experimenting with electric propulsion, ion drives that glow like blue fire in the vacuum of space, and materials lighter and stronger than anything we've ever used before. Each new step brings us closer to a future where the distance between Earth and the stars is measured not in dreams, but in flight hours. Yet, for all its triumphs, aerospace engineering is also a story of risk. Every launch carries with it the possibility of failure. Every new aircraft must prove itself through tests that mimic the harshest conditions imaginable. Wings are bent until they nearly snap. Engines are run until they melt. Rockets are shaken as if by earthquakes and frozen as if in the cold of deep space. These trials are not punishments, they are proofs. Only through this crucible can engineers be certain that when a machine finally carries human lives or irreplaceable cargo, it will not fail. The stakes are too high, the margin for error too small. In aerospace, safety is not a guideline, it is the law. Behind all this technology is something even greater, the human spirit. Aerospace engineers are dreamers and doers, guided by equations but driven by wonder. They are the ones who look at the sky and see not emptiness but possibility. They are the ones who can take the most hostile environments, the vacuum of space, the fire of re-entry, the thin air at the edge of the atmosphere, and turn them into arenas for exploration. They work in silence, often unknown to the world, yet their creations define the very shape of modern life. Every time a plane takes off, every time a satellite beams a signal, every time a rocket lifts into space, their fingerprints are there, hidden but undeniable. The story of aerospace engineering is also the story of humanity itself, restless, bold, never satisfied with what is, always reaching for what could be. From the fragile flight of the Wright brothers to the thunder of Saturn V rockets carrying astronauts to the moon, it is a story of ambition that knows no bounds. Today, when we board a plane or watch a launch on television, we are witnessing not just a machine, but the embodiment of that ambition. Each rivet, each circuit, each calculation is a piece of that dream shaped by minds that refuse to accept the limits of gravity and atmosphere. And as we look ahead, the story is far from over. The next chapter is being written now, in laboratories where prototypes hum with quiet energy, in test facilities where engines roar like dragons, and in mission control rooms where new destinations are plotted on glowing screens. Will we build aircraft that make global travel as quick as local commuting? Will we establish colonies on Mars, supplied by fleets of reusable rockets? Will satellites become the guardians of our climate, watching and warning as Earth changes beneath us? No one can say for certain, but what is certain is this: aerospace engineering will be at the heart of it all, turning questions into blueprints, and blueprints into wings, engines, and rockets. When you look up at the sky and see a contrail streaking across the blue, or when you gaze at the night and see a tiny point of light moving among the stars, you are witnessing the living legacy of aerospace engineering. It is not just science, it is not just machines, it is humanity's eternal desire to go farther, faster, higher, and deeper into the unknown. It is proof that we are not content to stay where we are. We are builders of bridges, not between cities, not between nations, but between Earth and the sky, Earth and space, Earth and the infinite beyond. And so the story continues, from wooden wings to carbon fiber giants, from the roar of jet engines to the silence of orbit, from the first flight across a field in North Carolina to the first steps on the moon. Aerospace engineering has carried us farther than we ever dreamed. The journey is not finished, because the sky is not the limit. It is only the beginning.